Did I get my calculators back?
So many dead brain cells.
You know, it's savage why you drop it so.
Where's Chrissy? Alright, here we go. Find all the asymptotes. Okay, oh my goodness. Dig back in your brains. That's what we have to do. We want all the asymptotes. Who has an idea how we might start this problem? We're going to factor the bottom. We almost always factor if we can, right? No matter what kind of problem it is. So we're going to factor the bottom. And how does the bottom factor? Minus 5 plus 1. Very, very good. So now we have vertical asymptotes. Now it doesn't ask me to graph it, but I'm going to go ahead and just put them on here so you can see what they look like. We're going to have vertical asymptotes at x equals 5 and at x equals -1. So if you have forgotten that, I want you to put a little notation over to the side. Vertical asymptotes make the denominator 0. Okay, is everybody doing that? Put a little thing over the side. Vertical asymptotes make the denominator 0. Okay, and that's what would make the denominator 0. Now what about the horizontal? This is a super tricky problem. Where's the horizontal? We look at the x's on top of the x's, and ideally they'll match, so that we would have something like 2x squared over 3x squared, and then the asymptote would be at y equals 2/3. Do you remember that? What happens if they don't match? These don't match. The big one's on the bottom, so the asymptote is at 0. Y equals 0. Your horizontal asymptote is y equals 0. So, to review, if they match, it's just a fraction. So, 2/3. If they don't match, and the big one is on the bottom, which is what we have here. See what I'm saying when they don't match? I have x squared. If the big power is on the bottom, the asymptote's at 0. What if the big power is on the top? There isn't one. There is no asymptote. Whew, let's hope we remember number 2 a little better. Let's see. Find the remainder. We can divide, and if we were going to divide, Chris, what would go out here in the box?
-2.
-2, very good. Now, with synthetic division, I might try to trick you. Do you remember that when you do synthetic division, sometimes you put zeros up here? When do we put zeros up here? If there's a skip. Good way to describe that. If there's a skip in the powers. I don't have any, so I'm good. This number comes straight down, right? Always, whatever it is, straight down. Now, -2 times 2 is -4. Add. -2 times -8 is 16. Add. -2 times 25 is -50. Add. What did I do that for? To find the remainder. So, what's the remainder? -51. The remainder is -51. This is a very scary looking equation. Very scary. But the directions say, what is the Y-intercept? GQ boy, you want to get yourself in uniform?
GQ boy, what does that mean? Yeah,
There's a magazine called Gentleman's
I know what
Quarterly.
GQ is.
Alright, you want to get yourself in uniform.
Sure.
How do I find the Y-intercept? Oh,
Said x equals
I
0.
let x be 0. Kids, you let x be 0. To find a y-intercept, you let x be 0. Make a note. It doesn't matter how ugly the equation is. If you want the y-intercept, you're going to let x be 0. Okay, so tell me about that. what is 0.3 to the 0? 1. So that's just 1. So I have 28 over 3 plus 4. 3 plus 4 is 7. So I have 28 over 7. So the y-intercept is 4. How do I find a y-intercept? I let x be 0. Always, always, always.
There you go.
Okay. Now, how do I solve something like this? This has been not too long ago. First of all, I factor over here, right?
Yep.
So that would be x plus 2, x plus 1. And then we multiply everything by x plus 2, x plus 1. Now what happens? What did I do that for? I can cancel. So out go the 1's, x plus 1's I mean, and I'm left with what here? What would I be left with? X squared plus 2x. Okay, then these are going to cancel, and I'll be left with
2x plus 2.
2x plus 2, and then it equals nothing left except 7. Alright, so should we clean it up probably, huh? So x squared plus, let's add these together, 4x. Let's move the 7 over, minus 5 equals 0. With me, Ethan? Or what should I do with that? That factors. If you don't want to factor it, could you use the quadratic formula? Yep, but it does factor. How does it factor? Plus 5 minus 1. So what does x equal? 1 and negative 5. Now, want to make sure those don't make any zeros. They don't, we're good. So here we go. Remember, whatever numbers you get, you have to be able to put back in and not get 0 in the denominator. So 1 is fine, 1 plus 1, and negative 5 plus 1, everything's fine.
Would it ever not factor once you get to that point?
It could not factor once you get to that point, and you'd have to use the quadratic formula.
Because I feel like we were a couple times where it didn't factor.
Yeah, that's definitely possible. And then number 5 says solve. Now, it doesn't tell you how you have to solve it, so I want you to do it however you can remember to do it. So I'm going to look at this problem. Lots of questions on the exam, so we just kind of have to go with what occurs to us. When you look at this problem, what do you think about doing? Adding 4. I love that idea. I think that's a great idea. Okay, now, the absolute value of 3x minus 1 can either equal 6, or what else can it equal? Negative 6, remember? What's inside this thing could be a positive 6, because the absolute value of 6 is 6. It could also be a negative 6. So I'm going to get 2 answers. One answer is 7/3, and the other answer is negative 5/3. And those are the answers to the question. Okay? I know there's a lot of information, isn't there? A lot to remember. Okay. This one looks kind of easy. I don't know. Maybe it is, maybe it isn't. Let's see if we can remember how to do it. Do you have any thoughts on that? Yeah, be careful, we got a couple of inequalities in there, so I'm probably not gonna be doing any factoring here. What I'd like to do, thank you, Marley, we're on our packet, a review, exam review packet. What I'd like to do is get x by itself. I'd like to have the x all by itself. So I could add 4, but here's the tricky part. You have to add it to all the pieces of the problem. This is a piece, this is a piece, and this is a piece. This is called a compound inequality. Can you see that it has 3 parts to it because of the 2 symbols? So when you say I want to add 4, I think that's a wonderful idea, but you have to add it to everything. Now what? To get x by itself, now what? 3. Divide by 3. So 2/3 is less than x is less than or equal to 15/3. Now, that answer just comes out like that, but caution, if this is on the multiple choice part of the test, the answer may not be written like this. It may be written like this. Does that make sense to you? First of all, 15/3 is 5. And in interval notation, the plain symbol is the parentheses and the or equal to is the bracket. So these are the same. You need to recognize that because part of the exam is multiple choice. Okay? And all of the pre-cal teachers work on the exam together because some of the questions are common. So in other words, you're going to be taking the same questions as the academic kids and the honors kids, some of them. Not all of them, obviously. Okay. All right, next, solve. All right, how do you want to do this? Quadratic formula, what a great idea. Some of you have already looked at it and said it doesn't factor, and you're right. If it did, you could, but it doesn't. So what's the formula say? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, you got to have that memorized, okay? And it might help you to somewhere write down your A, your B, and your C. You don't have to do that, but it might help you stay more organized if you did that. A is 1, B is -7, C is 4. Right, Joseph?
Yeah.
Your eyes open?
Yeah.
So 7 plus or minus the square root of, what do we got under there? 49 minus 16, which is 33. Is that right, 33? And 33 does not break down, so I'm done. I am done. Eight. What's the domain? Anybody remember? What'd you say, Deshani? -2. Okay, now the domain isn't -2. The domain is x can't be -2. Your domain is x is not equal to -2. Because what happens if you put -2 in? You get a 0 in the bottom, which is no go, right? Okay. Number 9. Alright, we're going to do a few more together, and then I'm going to have you do a couple on your own, okay? We'll do a couple more together. Let's do this one. What do I do here? Plug x plus 1 in for the x's. So every place I see an x, Paul, you are exactly right. every place I see an x, I'm going to put in an x plus 1. So I'm going to have 3x plus 1 squared minus 2x plus 1 plus 1. So I put an x plus 1 here and an x plus 1 here. And now what?
Don't you square what's in parentheses?
I square what's
Or
in parentheses, and what that means is FOIL, right, Chris?
Yep.
That's going to be x plus 1 times x plus 1. So that's x squared plus x plus 1, which is x squared plus 2x plus 1. That's FOIL, but it's still got to be times 3. So it's 3x squared plus 6x plus 3. Ooh, is that the answer? No, I forgot all that other stuff, right? Minus 2x minus 2 plus 1.
Yeah.
Combine like terms, and we'll get our final answer. So it looks like it'll be 3x squared. That's that one. These two make a plus 4. And 3 minus 2 plus 1 plus 2. There's your answer.
Would you have to?
You don't have to do anything to it. Great question. No. Stop. That's it. It says, the problem says, what happens if you put in x plus 1? That's what happens. It's not solved, it's not anything, it just stops right there. Okay, and you'll probably see that because that'll probably be a multiple choice question. Okay, number 10. Number 10. Last one I'm going to do, and then I'm going to have you do some if you know how. So here we go. Oops. Anybody remember what to do if we're finding f of g of x? Anybody remember?
Put G of X into F.
Put g of x where?
Into F.
Exactly. So every time I'm putting g into f. So every time there's an x, I'm going to plug this in its place. I'm putting the g function into the f function. So I have this x plus 2 squared minus 3x plus 2 plus 1. This is sort of like that one right there. We are taking whatever g equals, which is x plus 2, this is x plus 2, and we're plugging it into our f function. All right, FOIL it out, collect like terms, do just what we did here and tell me what you come up with. Come on.
X squared plus x plus 1.
Don't just copy Mrs. Ford's. She's made 2 mistakes already today that I know of. And again, whatever you get, did anybody match me? Whatever you get, you just stop. Don't do it, don't like quadratic formula or anything weird, just stop. We only use the quadratic formula when we are solving, when the directions say solve. Okay? Now, in the next 11 minutes, we got to get the next page done, just the 4 problems on the next page. So, is there anybody who thinks you can do any of those problems, 11, 12, 13, or 14?
Nada.
Almost 11?
It's upside down.
Upside down.
It's an upside down what? Parabola.
Upside down, right.
Sitting where? Right 3 and
Up 1.
Done. You guys got it. Right 3 and up 1, upside down parabola. Perfect. Does everybody understand why they said right 3 and up 1? And why it's upside down?
Yes.
Excellent. That took like 30 seconds. Super. What about 12, 13, and 14?
The vertex. Can't.
No, there's a way to find the vertex. Can anybody remember?
Oh, y equals 2.
-2. No,
X.
something.
X equals
X equals 2 b over 2a.
negative b over 2a. So make a little notation. Negative b over 2a is going to give you your x. Okay? Now, that's going to give us our x. So in our problem, what's negative b?
12.
2a.
2 times 3.
So my x coordinate is 2. It didn't say find just the x. It said find the whole vertex, right? So how do I find the rest?
Plug it back in.
I plug in 2. So here we go. I plug in 2. And remember, you square first. So 2 squared is 4. So this is going to be 3 times 4. So 12 minus 24 plus 4. What is that? Negative 8. So your vertex is 2, negative 8. The purpose of reviewing is to jog those memories, right?
Yes.
Negative b over 2a. You probably aren't going to get every question right. But let's get these easy ones right. Negative b over 2a. Well, you might get every question right. All right, here we go. 13 and 14.
Not a chance. How much you charge it for these right here?
They're all here.
Listen, they were a treasured gift from a student. They're just there.
Do you not
Why did you
drink
not,
them?
why did you not consume them?
I might, but right now I'm just enjoying the fact she thought of me.
Well,
It's
then let me
nice.
help you
What's
with
it?
money-wise.
Buy a Pop-Tart.
Like Pop-
Okay, all right. Anybody remember 13 or 14?
13.
On 13, here we go. Listen, what?
Well, for the first part, would it would be x plus 2.
All right, stop. She says it would be x plus 2 squared. Now, I think some of you saw all those words and just skipped it, so I can't do it. Yes, you can. It says we're starting with x squared. Joseph, sit up. Sit up. X squared. We're starting with x squared, and we're shifting it to the left 2. Would this shift it to the left 2? Yes. Now we want to vertical stretch it by 3. How do we vertically stretch? Put a 3 in front. That's exactly right, Paul. That number in front is your vertical number. If you multiply by bigger than 1, you're stretching. If you multiplied by 1/5, it would shrink it. And then a vertical shift of 1 unit. Plus 1. See, you guys remember it once we talk about it a little bit. There you go. I used the squaring function because that's what the problem said. It said use the squaring function, x squared. All right, 14. Okay, you can do this. Common sense. Use interval notation to list the intervals where the function is increasing. Now, what do you think increasing means?
Going up.
Going up. So, if you were to draw this picture, so let's see, I got a point here, and I got a point here. Okay.
That's real.
So this is what the picture looks like roughly. Would would you say I'm increasing on this branch?
No.
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 How about this branch?
Yeah.
Okay, so from this x value to this x value, I'm increasing. Right? I'm moving left to right, so I'm looking at the x's. As I go left to right, I'm going up, right? But wait a minute, aren't I still going up?
Yeah.
Till I get to here, right? Which is an x value of 1. So everything from -3 to 1, I am increasing, and it says use interval notation. So I say, okay, my parentheses, everything from -3 to 1, I'm increasing. Now, am I increasing anywhere else on the picture?
Yes.
From here to here. So that's from 3 to 4. So I'll say or, that's my union symbol, from 3 to 4. And that would be the answer to the question. Those are the places where you are increasing. Okay? All right. Somebody remember tomorrow,
I got you. What do you need?
no, Monday.
We don't see
Somebody
tomorrow.
remember on Monday that we start with number 15, okay?